Wave-particle duality is perhaps one of the most confusing concepts in physics. Before the 20th century, scientists believed that light was only one of them, either a particle or a wave. However, later it was proved that it actually is both. Scientists believe that light was a wave because it had a frequency and it had a wavelength. However, what really changed that notion was the photoelectric effect. The photoelectric effect says that if there is a photon that strikes a metal surface, it ejects an electron. This is what introduced the idea of light being a particle because only particles can eject other particles. Also, it was experimentally observed that if you have light below a certain frequency, minimum frequency called the threshold frequency, no matter how intense the light may be, it will not be able to eject an electron. And no matter how many photons fall on the metal surface, it will not be able to eject an electron. However, if you even have one photon of very low intensity but a frequency above that minimum frequency, it is still capable of ejecting an electron. Max Planck proposed that energy is not continuous, it is quantized, which means that light also is composed of small packets of energy that are called as photons. He also extended this theory to say that actually everything is quantized, even space time, which means you can't divide it infinitely. As you keep on dividing it further and further and further, you will be able to reach a smallest value that cannot be divided any further. Einstein proposed, Einstein extended this theory to light and he said that light is composed of, as I mentioned before, quanta, which are called as photons, which are nothing but the particles of light. As a result of this, the wave particle duality theory came into existence, which basically means that light is both a wave and a particle.